Okay, picture this. You're sitting in the exam hall, the clock is relentlessly ticking down, and you are staring down a massive, high stakes, extended response question for Cambridge Physics 9702. You write down an answer that feels, absolutely rock solid. It sounds like physics, it feels like physics, but what if I told you that one tiny, seemingly harmless vocabulary slip is about to completely tank your entire answer? Today in this explainer, we're tearing down the exact traps that literally hemorrhage critical exam marks, and we're going to build flawless responses instead. Just listen to this actual, real-life student answer. Dielectrics are insulators that allow free charges to move and conduct current when an electric field is applied. Now, I want you to read that carefully. This exact phrasing right here, it is a massive, massive trap. Sure, it kind of looks scientific at a passing glance, but it is fundamentally broken at the very core of solid-state physics. Let me be blunt with you. If you write that exact sentence in your 9702 exam, it scores 0 marks, period. A flat 0. It's the kind of fundamental physics error that completely risks your grade boundaries and totally destroys your confidence. And why? Because the student completely missed what's actually happening inside an insulator when it's put under an electric field. So let's talk about why your ordinary revision is probably failing you here. How do we actually fix this? Look, relying on rote memorization just absolutely does not work for Cambridge-style extended questions. If you're just flipping through flashcards without really grasping the underlying mechanics, you are inevitably going to write down contradictory nonsense, like insulators that conduct. The real issue we're seeing here is confusing labels with actual explanations. Just throwing a label out there, like calling a material a dielectric, without actually linking it to the atomic arrangement, the bonding, or the carrier motion, that is literally the most painful common mistake we see learners make. You simply cannot just hand the examiner a label and expect a mark. You gotta give them the mechanism. Which brings us right into the core of it, connecting the microscopic cause to the macroscopic effect. If you want those top-end marks, you absolutely have to understand this foundational concept. This is where the real physics actually happens. Take a close look at this precise definition of polarization on the screen. It's defined as the displacement of bound charge in a dielectric under an applied field, altering the internal field without free current conduction. Do you see it? The crucial takeaway here is that polarization is entirely about bound charge displacement. It is 100% not about free charge conduction. Charges in a dielectric can't just move freely through the material like they're on a highway in a conductor. They just shift, slightly. But let me tell you, that tiny little shift, it's everything. So to avoid getting these concepts twisted, we use this super effective 3-part model. Let's walk through it together. Whenever you're tackling a macro topic in solid-state physics, you need to constantly be asking yourself these 3 questions. Step 1, what exactly is the structure or process? Step 2, why does it happen? And step 3, what observable effect does it produce in the real world? This specific framework takes a rigid, memorized one-liner and turns it into a structured, highly usable understanding. Your exam paragraphs can and honestly should literally be built around this mechanism and consequence flow. In a moment, I'll show you the exact examiner clue that changes your calculation entirely. But first, you need the framework that makes that clue obvious. Let's look at the top band answer framework. This right here is the elite framework you need to construct a totally flawless Cambridge exam answer. You simply can't just throw random facts at the page and pray something sticks. Here is how you logically build that winning answer. First, step 1, you state the concept. Then, step 2, you provide the evidence or data. Moving to step 3, you apply your scientific reasoning. And finally, step 4, you wrap the whole thing up in a nice bow with precise examiner wording. Structured, disciplined prose is always going to outscore a messy, unplanned list of facts. You've got to explicitly map that microscopic charge displacement right back to the macroscopic field effects. And honestly, this 4-step flow guarantees you won't miss a single beat. Okay, let's play a game. Let's spot the fatal error. I want to put you in the examiner's seat for a second with a real-world application, like capacitor design. Check out this claim. A capacitor's dielectric constant determines its energy storage. Now, I want you to pause and predict. What external constraint is totally missing from this claim? A top band student would look at this and instantly recognize that in those chunky extended questions, just stating a property is never going to be enough to get full marks. So what's the missing variable? Got a guess? Well, let's see how you did. Did you think of temperature? What about purity, structural order, or maybe external field strength? When you're writing those extended answers, applying realistic constraints often magically unlocks that final elusive mark. By bringing up these external constraints, you're literally proving to the examiner that you understand how real materials, like heavy-duty insulating tables or tiny embedded electronics, actually have to survive strong electric fields and wild temperature swings out in the real world. That right there is how you secure the bag and get that final mark. So, what does a flawed answer look like next to a flawless one? Let's check it out. Let's bring all this theory together and actually compare our disastrous cold open mistake with a perfect top band answer that uses our brand new framework. On the left side, we have our flawed answer. It stores energy because it's an insulator. Honestly, it's just a label. Nothing more. But now feast your eyes on the right side, the flawless answer. Applied field causes microscopic bound charge displacement, modifying the macroscopic field and increasing energy storage capacity. Wow. Do you see how applying that framework just completely transforms the entire response? We smoothly travel from the microscopic cause, which is the bound charge displacement, straight to the macroscopic effect, the increasing energy storage capacity. That leap takes you straight from a big fat 0 to a glorious top band score.
Let's lock this in with a quick recall summary.
As we start to wrap up this explainer, I want to give you a rapid-fire recall checklist. In fact, I challenge you to practice recalling these 4 trigger statements in under a minute when you're feeling that exam pressure. Ready? Defining idea, charge displacement. Mechanism, internal field alteration. Property, energy storage. Application, capacitor design. Let me repeat that one more time because it's that important. Defining idea is charge displacement. The mechanism is internal field alteration. The property is energy storage, and the application is capacitor design. If you can instantly call up those 4 pillars on test day, I promise you, you will never get lost in a dielectric question ever again. But hey, here is the really scary thing. Let's say you've got the absolute perfect physics explanation memorized down to the letter. But what if you misinterpret the specific command word that actually decides your mark band? If a question specifically tells you to evaluate and you only describe, well, even the most gorgeous, flawless physics explanation is going to fall completely flat on its face if that command word issue is left unresolved. This is the ultimate lesson of advanced physics. The macro is always governed by the micro. Exam boards aren't just testing your rote memory. They are actively testing your ability to connect the invisible atomic world to the tangible forces we experience every single day. So the next time you sit down to write a response, ask yourself, are you just lazily giving them a label, or are you finally showing them the mechanism? To find out exactly how to decode those tricky command words and stop losing silly marks, subscribe to our YouTube channel, Ace the Exams, at acexams_IGCSE to excel in your Cambridge examinations.